Okay, good morning, guys. Thank you very much for joining me on what day is it today? I lose track on a bank holiday weekend. It's a Sunday morning, and it's good though because it means you should be getting up nice and early, get some revision done. We'll do a few exam questions today from Corpio. It says AS Corpio there, but we'll be doing some from either AS or from A2. Yeah, I just hope things have been going for you for your studies. We're really in proper exam season right now. If you've been to one of these before, you'll probably know how this works. I need to get my calculator ready, really, don't I? We're going to be picking some random questions from this. I'm going to see if this has actually gone live. I never know when these things actually have gone live. It's a very, very strange experience to do this when you just sort of start talking in your room to yourself. But anyway, we'll get started and see if you can tell me if you haven't seen anything yet in the chat. That's always really helpful for me to know what is going on. Okay, so I'm actually going to pick one of these questions. I've only just woken up. I don't know why I picked to do this on a Sunday morning right here, but I have done. And we're going to get started with a question. And I really hope it's not too hard because this is not a good warm up for me. I need to check actually how many slides we've got here. So it's between 1 and 318. So I'm going to be doing this between 1 and 318. I wonder why this isn't working. There we go. I am on. Okay, so between 1 and 318. We're starting with 110. I'm not really sure what that is going to be roughly in the document. So let me just quickly jump ahead here. And we're going to go to 110. We'll be doing this until 10:30. Okay, so this is an AS 2022 paper. And it's got, I'm just going to write down what these matrices are. So I have that A is 4 minus 1, 7, 2, minus 5 and 8. B is 2, 3, 2, minus 1, 6, 5. And then C is a very big matrix. Hopefully I'll fit this all in. Minus 5, 2, 1. I haven't even read the question, but I know I'm going to want these on my page so that I can refer back to them. Ooh, almost wrote that one down wrong. Okay, and it says, given that I is the 3 by 3 identity matrix, show that there is an integer an integer k for which AB minus 3C plus KI is equal to 0, stating the value of K. Okay, good. As long as all of that is showing on my screen that we've got there. So I'm going to first of all just quickly work out what AB is. We could do this manually or we could do it on the calculator, but I'm going to do this straight away. I'm not going to do this I'm not going to rewrite these matrices. So for my first part, I'm going to just double check what I've got here. I have a 3 by 2 and it's going by a 2 by 3. So I am going to get a 3 by 3 matrix here. I tell you what, I'm actually going to put this in my calculator. I'm going to double check on the mark scheme. I'm going to be allowed to do that. No, I think they do want it manually done. I'm not sure. Okay. You know how to multiply matrices. I'm going to put it on my calculator to do a bit of a time saver because I want to get through as much as we can do in this session. So I'm going to be using this one that we've got here. And let's delete all of this other maths that I've got going on. And I'm going to do A multiplied by B. So I think I put that in as an option. No, I don't. Here we go. So it is a m by n. So I want it to be a 3 by 2. So that's 4 minus 1, 7, 2, minus 5 and 8, multiplied by a 2 by 3, which is a 2, 3, 2, minus 1, 6, and 5. And so it's actually given me that matrix for this AB part that we have, which is 9, 6, 3, 12, 33, 24, minus 18, 33, and 30. And I'm going to be subtracting 3 lots of C. So I'm just going to multiply all of these ones by 3. So that's going to be a minus 15, a 6, a 3, a 12, a 9, a 24, a minus 18, a 33, and a 6. And then it's going to be plus K lots of I, which is just going to be a K, K, and another K here. And then all of these zeros. And we want all of that thing to just be equal to 0. But so I can kind of squeeze it on the page. I'm just going to write it as a single 0 like this. So I actually probably didn't need to do all of these bits because actually, did it say show that it's true? Yeah, so I actually have to probably do all of these as an addition. So I am going to very quickly get a 6 minus 6. I'm going to get a 3 minus 3, a 12 minus 12, a 24. All of these ones match. So those are all just going to be zeros. But the other parts are going to be a bit more interesting. So I have the 9 minus 15 plus k. So 9 9 minus 15, that's 9 plus 15, that's 24. So that's a 24 plus k. And we can have a 0, a 0, a 0, a 0, a 0, a 0, and a 0. Presumably, 33 minus 9, that's also going to give me a 24 plus k. Whoops, not down there. Definitely a Sunday morning. And a 30 minus 6 plus a k is also a 24 plus k equals 0, which just means that we need to have a 24 plus k being equal to 0. So k is equal to minus 24. Okay, the next part of the question says explain why there can be no constant m such that this is true. So for that second part of the question, the thing that's different is we now have BA instead of AB in this case. And if you look at the dimensions of BA, it wouldn't work in terms of the multiplication. So when we did AB that was up here, we had that A was a 3 by 2 and B was a 2 by 3. And the fact that these kind of matched each other, that gave us a 3 by 3 matrix that we have. But if we do a B times A, that would be a 2 by 3, and A is a 3 by 2. So we can actually work out what BA is, but a 2 by 3 times a 3 by 2 is going to give us a 2 by 2 matrix. And then the rest of this equation that we have, which is our, what is that, BA minus 3C plus MI, where I is a 3 by 3 matrix, we won't be able to do that because BA will be a 2 by 2 matrix, but the C and the I part will be a 3 by 3 matrix. So I'm just going to move this piece of paper up a bit so I can explain that. So I'm just going to say that BA is a 2 by 2 matrix, whereas the C and I matrices are 3 by 3, so the dimensions do not match. We'll look at their phrasing afterwards to see how they describe this, but that should be enough for us to say that dimensions do not match each other. I'm just going to pull this up so that I've got the chat screen that I've got here as well. Okay, the last part of this question, this is quite a nice one for us to have started off with because it's not too crazy. I'm going to get a new piece of paper for this. So we have explain why, or show how the matrix C can be used to solve these simultaneous equations that we've got, and hence use your calculator. Okay, this is a really, really easy one. So the simultaneous equations are minus 5x plus 2y plus z equals minus 14. We then have the 4x plus 3y plus 8z is equal to 3. We have the minus 6x plus 11y plus 2z is equal to 7. So because they want us to show how this works, we're just going to take the C matrix, which is minus 5, 2, 1, our 4, 3, 8, and our minus 6, 11, 2. That is all getting multiplied by x, y, z, and that gives us our minus 14, 3, 7. So to find out what XYZ is, XYZ would be the C matrix as an inverse, which we could actually just write as C inverse applied to minus 14, 3, 7. I'm only writing it like this just to kind of save some time with this sort of stuff that we have, okay? But you could, in theory, just write it with the inverse bit. And then it says just use your calculator to solve this. Well, to use the calculator to solve this bit that we've got here, I'm actually probably going to be really lazy. I'm just going to type in the stuff that we've got at the top there because I think that is going to be probably quicker for me to type on my calculator. So I'm going to just jump to, because they'll never know which way I've solved it. They don't know if I've done it using matrices or whether I've done it with the simultaneous equation solver. So very easy. I'm just going to get all these numbers whacked into the calculator and hope I haven't pressed anything wrong. So it looks like we have that x is 3.5, y is 3, and z is minus 2.5. But that should be enough. I'm going to be interested to look in the mark scheme. I maybe shouldn't be rushing as much for these live streams, but let's see what we've got. So this mark scheme is very, very small to see here, but it looks like we've got most of the stuff. Yeah, the first part was fine because we got that k was minus 24. And then for part 2, it said we needed 2 things. So BA is a 2 by 2 matrix, which is fine. And then we don't have matching dimensions because of the 3 by 3 matrix that we have there. And then for the next part, actually, I think I probably won't have the method marks for this next part of the question. So I did get this correct and this correct and this correct, but actually they want more information. They want actually to know what the inverse matrix of C is. So I think if I was doing this in the exam, I perhaps wouldn't have rushed through this. So actually, this does need to be worked out on the calculator. I'm going to reread the question and see if there was something there that told me that that was necessary. Show how the matrix C can be used to solve the simultaneous equations. I thought they would accept it just as a C inverse, but we do need to have it fully worked out on the calculator. You can see that in the mark scheme that we've got here. If I just zoom in a bit, they are actually expecting to see the kind of fully evaluated matrix, which is interesting. I wasn't expecting it to be done like this. Interesting. Okay, probably would have only dropped 1 mark for that bit to have not got that. I don't know. Looks like maybe it would be okay. I'm not totally sure on that one. We shall see. Okay. So let's try another question that we've got here. I saw in the chat, is my calculator even allowed? Of course my calculator is allowed. I'd never use one that we couldn't use. So we're going to do 239 for the next question. 239. Thank you for joining me on this Sunday morning, for anyone who's just come along. Okay, we'll do the next one along here, which is this one. So we've got a nice substitution integration question, and it's from A2 2019 paper 2 that we have here. I'm just going to check that I'm on the screen so that I can see this properly. Good, I can do. Okay, fantastic. So the question is that we have f of x is equal to 1 over the square root of 4x squared plus 9. And it says, using a substitution that should be stated clearly, show that the integral of f of x is this kind of thing that we've got here. Now, there's a big clue in the thing that we've got. The big clue that we have is that we have the inverse sign, which makes me think that the substitution is going to be something to do with sign that we have got here. Okay, so I think it's important that we've got let me decide what the substitution would be. It's definitely going to be to do with sign. I'm also going to grab my formula book for this so I can double check that I'm using the right part. Yeah, so I'm looking at the integration section for the formula booklet. Let's see if I've got it here. Yeah, here it is. Confirming that we've got it in this kind of form. So we're looking at something that's kind of in this sort of form that we've got here. So I really kind of want to have the x part with a coefficient of 1. I'm probably going to actually try and create that coefficient of 1 for this. I never know if I've got things on the camera properly. Yeah, I'm going to try and get the coefficient of 1 for this to start off with. So I'm going to do a little bit of manipulation before I even do the substitution. I'm actually going to take out a quarter from this part so that I would have it as 1 over the square root of 4. And then that would leave me with the square root of x squared plus 9 over 4 like this. You could go straight in with a substitution, but I find this a little bit easier to do. So this is actually 1 over 2, the square root of x squared plus 9 over 4. Now at this stage, I'm going to just say that my substitution is going to be that x is going to be equal to shine u. I know it's going to be x equals shine u because in the answer that we've got, there is an inverse shine that we have. And I'm just going to double check that this part here will work when I do some sort of substitution. I wonder if this is going to be the one that I want to pick. I think I might need to change this coefficient. So I might have to say that x is a shine u, and I'll see how I can find out what that value of a will be in a second. So when I do my x squared plus 9 over 4, that would be my a squared shine squared u plus 9 over 4. Okay, I think I know what a is going to need to be, because I need to have this value here matching this value so that I can use one of the hyperbolic identities. So instead of using a, I'm actually going to use the square root of this part, because if I say that a squared is 9 over 4, then a would be 3 over 2. So my substitution is going to be this. X is equal to 3 over 2 shine u. So that when I do my x squared plus 9 over 4, I would have 9 over 4 shine squared u plus 9 over 4. And if you think of your hyperbolic identities that we know that we normally have that cos squared plus sine squared is equal to 1. So for our hyperbolic ones, this would be cos squared minus sine squared is equal to 1. So when I rearrange this, I can see that cos squared is sine squared plus 1. Sine squared plus 1. Which means that this whole thing is 9 over 4 cos squared u. So this is 9 over 4 cos squared u. And so the square root of x squared plus 9 over 4 is 3 over 2 cosh u. Now, you probably could have done this substitution at the beginning with just a different value of a. You probably didn't need to do all of this factoring out, but I have done, so I'm going to have to run with the way that I've done it now. Now, using this, I'm also going to have to do my substitution for du dx, because eventually what I'm trying to integrate is this thing, right? I'm trying to integrate 1 over 2 root x squared plus 9 over 4 dx. So I need to find out what dx is. So I'm going to differentiate this, and I get that dx du is 3 over 2 cosh u, which means that dx is equal to 3 over 2 cosh u du that we have. So I think I've got all of the information in this bit up here to start doing this integration. So doing the substitution, it's going to be 1 over 2. The square root of x squared plus 9 over 4 is 3 over 2 cosh u. And then dx is 3 over 2 cosh u du. So the 3 over 2 cosh u completely cancels out, and we're just integrating 1 over 2 du, which is just going to go to a half u plus c. Okay, I think I've probably made a bit of a meal of this question by doing this bit at the beginning. I don't think I necessarily needed to do that bit, but it's still going to work out. We're still going to get the right thing. So I'm going to get my half u plus c. My u, well, let's just quickly rearrange what that is for u. My page is getting very messy. So this would be, let's actually rearrange it over here. So we have 2 over 3x is equal to sine u. Just rearranging this x here by multiplying by 2 and dividing by 3. So u is the inverse sine of 2 over 3x. So our final answer is a half inverse sine of 2 over 3x plus c. Okay? Now, this is when I haven't done much prep on this stuff, so this is what happens when I do these questions. Then it just wants us to find, in terms of natural logarithms, the mean value of f of x over the interval 0, 3. So if we're going to be doing the mean value of f of x, that just means we're going to integrate it between 0 and 3 and also divide by 3. So the mean value of f of x, that means we're going to integrate it between 0 and 3. And we're also going to divide at the beginning by a third. That's kind of our standard way that we go about doing these kind of mean values that we have for stuff. So I'm just going to be doing a third, and then inside here, I'm integrating. Instead of writing it as inverse sine like this, I'm going to write it as r sine of 2 over 3x. We no longer need the plus c. And I'm also going to remind myself of what the formula is for r sine. I'm going to just grab that from the formula book here, which luckily I did remember to bring. So the formula book for r sine x is, put this on the camera so you can see what I'm about to write down. It's this one, which is my ln of x plus the square root of x squared plus 1. So that's the ln of x plus the square root of x squared plus 1. So now doing some of these substitutions, I'm going to have the third. I'm then going to have a half of r sine of 2 over 3 times 3. That's just 2, so that's r sine 2. And then I'm going to be subtracting a half of r sine 0. Now, r sine 0 is just going to be 0. I think we remember that from the definition. So I have a third times a half for this bit. This whole thing is 0. I just need to do r sine 2, which is going to be the ln of 2 plus the square root of 2 squared plus 1, which is 5. So it is a sixth ln of 2 plus root 5. A sixth ln of 2 plus root 5. This is where I really hope that I've got this all right. So I do have the sixth ln 2 plus root 5. And I think they could have done a better, and I did have the right substitution of the 3 over 2 sine u. There are other ways, because it does say way number 1 here instead, okay? Okay, let's try another question. Gosh, this is a tough. Further maths is so much harder to do under pressure and in front of like a whole group of people online. It's much, much harder than just doing the normal math stuff that I know like the back of my hand. So let's go here. Let's pick another random number. Hopefully we'll get something kind of different. Let's see. We've got 294. Okay, 294. Whoops, I need to move that camera. 294. Okay, we have a differential equation. Oh man, here we go. Okay, we can do this. Let's just get this camera just where I want it. Okay, perfect. So we've got some coupled differential equations for this one. And it says, at the start of the year 2000, a survey began with a number of foxes and rabbits on an island. At time t years after the survey began, the number of foxes and the number of rabbits are modeled by these differential equations. Now I'm going to write them, instead of df dt, I'm going to write it as f dash. So f dash is 0.2f plus 0.1r. And then r dash, instead of dr dt, is minus 0.2f plus 0.4r. And we're trying to show, the thing that we're going to aim for is this. The aim is to show that the second derivative of f minus 0.6, the first derivative of f, plus 0.1f is equal to 0. Now, I think I remember what you need to do for this. I think you need to make something the subject. I think I need to make r the subject of this one so that I have it in terms of f. And then I think I can substitute it in here and here. But this is the one I always find really difficult to remember. So if I call this one my equation 1 and this one equation 2, I think I'm going to try this. If it doesn't work, I'm going to look at the chat and see if I'm getting any of this right or not. So if anyone is telling me that I'm doing this the wrong way around, that's also going to be very helpful. But I'm going to make r the subject. This is one I always get confused which to make the subject of number 1. So that would give me, making r the subject, first of all, I'll times everything by 10. So I would get 10f dash equals 2f plus r, which means that r is 10f dash minus 2f. So now what I can do, and I've got my pens somewhere, that means that this r is now going to be substituted later on into here. So I also need to find out what r dash is going to be equal to. So I'm just going to differentiate. So r dash would be 10f dash dash minus 2f dash. And this can now be substituted, this r dash, it can be substituted into the second equation. So I'm now going to sub into 2. So this gives me, when I sub in, 10f dash dash minus 2f dash is equal to minus 0.2f plus 0.4 of this. So that's 0.4 of 10f dash minus 2f. And I'm just going to hope that this actually gives us the thing we're looking for. So that's 10f dash dash minus 2f dash minus 0.2f plus 4f dash minus 0.8f, and it all needs to be on one side with the f dash dashes. So I'm going to start with 10f dash dash, then I'm going to have minus 2 minus 4, so that becomes minus 6f dash, and then when I put the f's to the other side, that's going to be a 0.2 and a 0.8, which just becomes plus f, which is equal to 0. This was the thing we were aiming for, so everything needs to be divided by 10. So I get f double dash minus 0.6 f dash plus 0.1 f is equal to 0 for that part. So that's kind of a standard pattern that we should remember for these coupled differential equations about how to combine them. It's basically like a kind of posh simultaneous equations where you make r the subject of one of them to try and have it all in terms of f, which was here. And then that means you can find r dash and then substitute it into the other one that we've got, okay? So now that I've got that, I can actually continue with the rest of the question, which is just to find a general solution for the number of foxes on the island, and then we'll do it for the rabbits as well. So I'm going to start off with the equation that we just had, which was f dash dash minus 0.6 f dash plus 0.1 f is equal to 0. So it's differential equations now. I'll start off with my auxiliary equation, which is that m squared minus 0.6m plus 0.1 is equal to 0. You know what you need to do for this? You just solve this quadratic to find out the values of m. So I'm getting in my flow now. I think at the beginning I was like, oh, I needed to do a bit of a warm up. This is like going into an exam like completely cold and doing the exam in front of I've got 100 people watching this. Oh, very nice. We've got some imaginary values as long as I've typed it in correct. 1, 0.6 and 0.1. Oh, no, it's minus 0.6. Have I typed it in right? Yes, that's okay to have some imaginaries. So we have that m is equal to 0.3 plus or minus 0.1i. Cool. While I have a sip of water, tell me in the chat what this is going to go to. I think I know, but I'm going to confirm with you guys. Okay. So yeah, this is going to be let's have a look. I think it will be f equals, this is our general solution. It's going to be e to the 0.3t. And then the imaginary part, I think that's the thing that does the cos and sine. So I think it's going to be like p cos 0.1t plus q sine 0.1t. I think that's what it is. I'm going to be looking to see if that is the right thing that I've got there. So I think that's all I need for that first part of the question. Did it just say the general solution for the number of foxes on the island at t years? That is the general solution that I've got there. Shall I just quickly see if I'm going on the right track with this? Yes. Okay, they've given me like all of the marks for that straight away. That's kind of cool. Okay. So now we're going to do part C of the question, which is to find it for the rabbits. Now, from the previous page, we have got this thing here, this bit that's in blue. This is what I'm going to use to quickly find out what the thing is for the rabbits. I don't know why that was 4 marks. That's kind of crazy to me. That's why I was doubting myself. So for the rabbits from the previous page, it is 10f dash minus 2f. So that's my quickest way of finding it out for the rabbits. So I'm going to have to find out what f dash is by differentiating this. And I'm differentiating it with respect to t. So I'm going to need to use a product rule here. Now this is further maths. So I'm not going to be doing the product rule in some kind of slow way. I'm going to do it nice and quick. So I'll differentiate this and keep this the same. So that's 0.3 e to 0.3t, p cos 0.1t, plus q sine 0.1t. Product rule then means I need to keep this and differentiate this. So I will keep this and I will differentiate this. So cos is going to go to minus sign and there's going to be the 0.1. So it's going to be minus 0.1p sine 0.1t. Sine just goes to cos, so it's going to be a plus 0.1q cos 0.1t. Just going off the page there. Now, I could probably try and simplify this. Am I going to try and do that? Yes, I probably will. I'm going to put my e to the 0.3t to the front, and I'll see what that gives me. So there's going to be a 0.3 and a p for the cos. So that's 0.3p cos 0.1t. Now, I also have for the cos this bit, so I'm going to deal with that, and I'm just going to tick off the bits when I've done them. So there's my 0.1q cos 0.1t. And then for the sine bits, I'm going to have the 0.3 and the q. So there's going to be a plus 0.3q sine 0.1t. And I'm going to have a minus 0.1p sine 0.1t. Again, I'm going just off the page there. So when I put these together, I need to have 10 lots of this. And then I'm going to subtract 2 lots of this. So the rabbits is now going to be 10 lots of this thing. Well, I'm just going to multiply this, 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 and this all by 10. And then I'll subtract 2 lots of this one. So there's going to be a 0.3t at the beginning. And I'm now just going to deal with these things multiplied by 10, subtracting these things multiplied by 2. So that's going to be a 3p. Tell you what I could even do. I could simplify this by writing these things quicker, but I'm not going to do it for today. So I'm going to get my 3p cos 0.1t, my plus q cos 0.1t, my plus 3q sine 0.1t, my minus p sine 0.1t. So this is the 10f dash. This has all been multiplied by 10. I'm going to subtract 2 of these. So I'm going to subtract 2p cos 0.1t, and I'm going to subtract 2q sine 0.1t. And I'm going to simplify this because I think it's going to probably be useful later on. So the things that are cos, I have 3p for cos and q and minus 2p. So 3p minus 2p is p, so I just have p plus q cos 0.1t. And then for the sine part, I have a 3q minus 2q and a minus p. So that is a q minus p. So I have a plus q minus p sine 0.1t. Wow. Sorry, I'm throwing my pens down there in a dramatic way. We've now got 7 marker. There's still more to go. Okay, it says at the start of the year 2000, there were 6 foxes and 20 rabbits on the island. According to the model, in which year are the rabbits predicted to die out? According to the model, how many foxes will be on the island when the rabbits die out? Use your answers to part 1 and 2 to comment on the model. So it says at the start of the year 2000. So when t is equal to 0, we know there are 6 foxes and 20 rabbits. And we're going to have to try and use that to find out what P and Q are, basically. Okay, so we're just going to jot down that from the question that when T equals 0, this is so much harder than normal maths. It's such a reminder of the differences between them. I'm just going to basically substitute them in to the 2 equations. So this one that I've got at the top is here. So I'm going to say that the number of foxes is 6. So 6 is equal to e to the 0.3t. That's just going to be 1. It's just going to be equal to p cos of 0 plus q sine of 0. And you should know in further maths that cos of 0 is just 1 and sine of 0 is 0. So we've immediately found out that p is equal to 6. Now I'm going to use this second equation here to hopefully find out what Q is equal to. So this is the number of rabbits. So for the second equation, I'm now going to say that 20, the number of rabbits, is equal to, well, that thing's just going to be 1. I then have P plus Q multiplied by cos 0 plus Q minus P multiplied by sine 0. Obviously, we know that sine 0, like before, is just 0. So 20 is equal to P plus Q times 1, and P is 6, which means that Q is equal to 20 minus P, or 20 minus 6, which is 14. So we've now got our 2 formulae, and I'm actually probably going to write these out so that I have them in the question. So I now have that the number of foxes is e to the 0.3t. Where did I have that written before? P cos 0.1t. So that's 6 cos 0.1t. And then Q sine, which is 14 sine 0.1t. And then the formula for the rabbits is e to 0.3t. For rabbits, which is just here, it's P plus Q, which is 20. So it's 20 cos 0.1t. And then it was Q minus P. Q is 14 and P is 6. 14 minus 6 is 8. So we have 8 sine 0.1t. Now I've got to that stage with actually what the equations are. I'm going to jump back to the question and answer it. So it says, according to the model, in which year are the rabbits likely to die out? So for this is for part 1. The rabbits are going to be equal to 0, which means that if the rabbit is going to be equal to 0, let's give myself a bit more space on the page. I'm going to say that 0 is equal to 0.3t, 20 cos 0.1t, plus 8 sine 0.1t. Obviously, this thing here cannot be equal to 0. So 20 cos 0.1t is 8 sine 0.1t. I'm going to make tan here, so I'm going to divide by the cos like this. So I have 20 over 8. 20 over 8 is the tan of 0.1t. And then I'm going to just go to the calculator and hopefully solve this equation, obviously in radians mode for this, okay? So we must be in radians mode because we're doing trigonometry, calculus, I mean. So I shall do the inverse tan of 20 over 8. And then I'm going to times that answer by 10 so that I get t is 11.90. Now let's just remind myself what the question said. In which year are the rabbits predicted to die out? So they're going to die out if it's at the start of 2000. I think this means that they will die out in, I think this is 2011. Is that right? Yeah, because it's at the start of 2000. Yeah, it would be at the start of 2011. And then this bit means it will be happening during 2011. And then we will say how many foxes will be on the island when the rabbits die out. So we're now trying to find out what is the value of f when t is 11.902. Wow, they're making us work hard. So I'm going to say that foxes is going to be, and I'm just going to go straight into the calculator for this. You can't see it on the page, but I'm using this formula that we have. Actually, I can leave it on the page, can't I? So I'm just going to go in my calculator. I shall do e to the 0.3 of my answer, 6 cos 0.1 answer, plus 14 sine 0.1 answer. And I get that the number of foxes is 541. I might do actually show the substitution. I could probably show the substitution for this. And then it says, using your answers to part 1 and 2, comment on the model. So it's saying that, does this, probably what I would comment is, does it make sense that the rabbits are going to die out and there's going to be 541 foxes? Well, if the rabbits have just died out at this particular point, at this point, there's not going to be any more rabbits. So it's not going to kind of keep growing after that. And it's going to probably say something around the foxes being, like, how can the foxes sustain themselves if there are no rabbits left? So they're going to die out. Let's see how we did with these answers. So I have completely done something wrong here. What have I done wrong in this question? Oh man, I didn't put the minus. Did it need to be a minus? What have I got wrong? So I got that these were correct. So it said 2019. Let's have a look at this last part. Have I done? Oh, yeah, you've all got me because I've now actually looked at this bit. So there was a negative. Where was the negative that I missed? Oh, yeah. Damn it. That's a negative. Okay, so that should have been a negative here, which means all of this. And it's really hard to see the chat because there's like a bit of a delay with these things. So that's minus 20 over 8, inverse tan of that, and times 10. Actually, I have to plus pi and times it by 10. So it's actually 19.513. So it's 2019, and I'll sub in the 19.513. So I shall just very quickly fix that. So it's going to be e to my 0.3 answer. I did all the hard stuff. I just couldn't solve the basic equation, which is kind of typical of me. 6 cos 0.1 answer plus 14 sine 0.1 answer. And we do get 3,754. And they want it rounded to a particular thing. Yeah, it's fine. We got 3,754. So they've said the model predicts a large number of foxes on the island when the rabbits have died out, and this may not be sensible because they wouldn't have enough food or something like that. So apologies for my little negative that I missed there, but hey ho, it's easy to make these mistakes, particularly when you're on camera. I can't believe how long that question just took. Okay, so thank you for pointing out the error there, but we're going to go now between 1 and I think it was 318. See what we've got, 145. Hopefully that's a little bit easier than that one that we just did, because that was one of the last in the whole thing that we had. Proof by induction. Okay, do I want to do this proof by induction? I think we should do a harder question than this. I think this looks too easy. I think we should do something a bit more interesting. Let me know. Do you think we should try a different question for this while I have a look at the water? Should we do this proof by induction, or should we try a harder one instead? Because I'm looking through this question. The proof by induction for part A is very long to write out, and then part B is really simple series. I think you're probably wanting to do something a little bit harder than this kind of question. So I'm looking forward to seeing what we should try. Okay, I'm going to look at a new question. Let's see what 110 is. I'm just going to scroll through to 110. We've done 110 already, so let's try another one. 100. Very easy as well. Let's go to 247. That's going to be hard. I know I don't normally do this, but I want to come up with some much harder things for one of these live streams, so it feels like you're kind of getting something more useful from it. This question is crazy. Do we want to try this question? Or do we want to do it? Should we just request like a polar kind of question? So we've got a choice. Shall we do this methods in calculus question, which I might need to zoom in a bit so you can actually kind of see what it's talking about. But it's kind of similar to one we've already done. Maybe we should do a polar. I think we'll just should we just do a polar question? Yeah, we're going to do a polar question. Okay, I'm going to go to the home. I'm going to pick polar coordinates. So it's between 269 and 283. So we'll do 277. Fantastic. Let's do this one instead. Okay, let's do this one that we've got. So it's been selected 277, and it says here, let's see if I can still see this on the page. Good. It shows a sketch of two curves, C1 and C2, with these polar equations. The region R lies inside C1 and outside C2, as shown shaded in figure 1. For 9 marks, show that the area is p root 3 minus q pi. Great. Now I'm actually going to draw this because it's going to help me kind of figure out what's going on. So it looks like, if I was going to draw it here, we have got curve 1, looks like it's this kind of shape. And then curve 2, I think, is the other one that's underneath it. And I'm going to try and use my colored pens to talk about what is going on for this kind of area that we have. Now, I think we're probably going to need to find out where they intersect each other, and I'm probably going to do this as just like a half section of what's going on. So if I call the top one curve 1 and the bottom one curve 2, I think I'm going to begin by wanting to find out for curve 1, I want to find out the area for curve 1, which is this whole green section that we've got here. What I'm then going to do for that, so that's me finding out the area for curve 1. Then what I think I'm going to want to do is subtract from that the area for this section, which is in this kind of pink color, which hasn't come out very clearly on the camera that we have, okay? So I'm going to want to subtract from it the integral of curve 2. And then at the end, I'm going to want to take this whole thing and I'm going to want to double it so that I end up finding the whole of that top section that we've got there. So I'm going to write down a little list of things that I'm going to do here. First of all is I'm going to find out the angle where they intersect. Then what I'm going to do is I'm going to integrate curve 1. If I call that angle alpha, I'm going to integrate it between alpha and pi over 2. Then what I'm going to do is I'm going to integrate curve 2, and it's going to be between alpha and also pi over 2. And then I'm going to combine these things together, and I'm going to do the integral of curve 1 minus the integral of curve 2. Now, I'm going to see if anybody has got any suggestions, because I don't want to do this question and see if I've kind of got this completely wrong. So if anybody thinks that I'm going to do it, oh yeah, and I need to at the end say double it. So if I'm doing this wrong, please tell me, because I don't want to waste everybody's time as I go through this whole thing. And I'm actually going to jot down what I know that curve 1 and curve 2 are. So curve 1 is curve 1, let's write this proper, is r equals 1 plus sine theta. And curve 2 is r equals 3, 1 minus sine theta that we have. Okay. So I'm going to find out where these cross. So that means my first thing I'm going to do is make 1 plus sine theta be equal to 3 lots of 1 minus sine theta. Okay, nice easy equation to solve. 1 plus sine theta equals 3 minus 3 sine theta. Putting the sine theta to this side, I get 4 sine theta, and the 3 minus the 1 is the 2. So sine theta is a half. Without using my calculator, I know that the inverse sine of a half is pi over 6. So now I know that my alpha in this question is pi over 6. What I mean by this is the angle at this place here is pi over 6. So I'm going to be integrating between, actually I think I had these the wrong way around. This one is, no, they're both good, between pi and pi over 2. Sorry, pi over 6 and pi over 2. So I'm going to do this next thing, which is to integrate C1 between alpha and pi over 2. Okay, good. No one's saying anything that I'm doing wrong with this, so this seems okay. So I'm going to integrate curve 1. Now, remember when you do integrating of curve 1, you have to do a half r squared d theta. So what I'm going to do is a half the integral. R in this case is 1 plus sine theta. So that's 1 plus sine theta squared d theta. And I said I was going to be integrating this between alpha and pi over 2. So that's pi over 6 and pi over 2. And remember at the end, I need to double all of this. So that is the integral of 1 plus sine theta all squared is 1 plus sine 2 theta plus sine squared theta d theta. And this is between pi over 6 and pi over 2. Now, if you've watched my videos, you will know that I've said many times that you need to memorize the identity for sine squared theta using the double angle. So this is coming from cos 2 theta is equal to 1 minus 2 sine squared theta. But further mathematicians, I think, should memorize the fact that sine squared theta is a half minus a half cos 2 theta. So I'm going to just rewrite that for when I do the integration. So that I then have my integral of a half between pi over 6 and pi over 2, 1 plus 2 sine theta, plus a half minus a half cos 2 theta, d theta. A little bit of simplifying here of just collecting the 1 and the half together. So it's a 3 over 2 plus 2 sine theta minus a half cos 2 theta d theta. I'm speeding up a little bit to make sure that we get through some good bits of this question. So I'm actually going to do the integration. So it's 3 over 2 theta. This is going to be minus 2 cos theta because cos goes to minus sine, so I have to put the minus in there. And I know this will be a sine 2 theta, and I'll have to counter that extra 2 in the quarter because sine goes to cos. And that's between pi over 6 and pi over 2. So let's put in all of the values. So there's going to be the half here, and now I'm going to be doing inside these brackets 3 over 2 times pi over 2. That's going to be 3 pi over 4, 3 pi over 4 like this, minus 2 cos of pi over 2. Cos of pi over 2 is cos 90, which is 0. And then this is going to be sine of 2 times pi over 2, sine of pi, which is also 0. And from that, I'm going to subtract putting pi over 6 in. So 3 over 2 times pi over 6, that's 3 pi over 12, or pi over 4. And then I'm going to be subtracting minus 2 cos of pi over 6. So that's minus 2 cos of pi over 6 is root 3 over 2. So those 2's are going to cancel. And then I have the sine of 2 theta. 2 times pi over 6 is pi over 3. You could put this in your calculator if you want to, but I'm doing it without. So that's going to be minus a quarter. Sine of pi over 6 times 2 is sine of pi over 3, which is root 3 over 2. So I have the half. 3/4 pi minus a quarter pi, that's just pi over 2. And then I'm going to have the minus root 3. This is the only thing I'll probably do. So I have my minus root 3 over 8. And then it has a plus at the beginning because it's a negative and a negative. And I get plus 9 root 3 over 8. So this is pi over 4 plus 9 root 3 over 16. Okay, now we're going to do the next part, which is the half, the integral for the second curve, which was our 3, 1 minus sine theta, all squared. So it's going between pi over 6 and pi over 2. So it's going to be 3 squared, which gives me the 9. This is from the second curve. And then I have 1 minus sine theta, all squared, d theta. Okay, I'm going to put the 9 out the front. So I get 9 over 2, the integral from pi over 6 to pi over 2. And it's going to be a 1 minus sine squared theta would be 1 minus 2 sine theta plus sine squared theta. Now, it's actually really similar to the one that we did here, apart from the only difference is instead of there being a plus 2 sine theta, we have a minus 2 sine theta. So I'm probably going to be able to do a bit of saving some time here and go straight to the integration line, because the only difference is it would have had a minus 2 sine theta instead of a plus 2 sine theta. So this is going to be the only thing that's different, I think. Now, this might be making a big mistake doing this, but I don't think it will be. So it's going to be a plus 2 cos theta and a minus quarter sine 2 theta between pi over 6 and pi over 2. So we have the 9 over 2. When I substitute in the pi over 2 here, it's still going to be the 3 pi over 4. When I sub this part in, it's going to be 0 and 0. So there's still going to be the minus 0 and the minus 0. This is probably the only part that's going to be different. So when I put the pi over 6 in, I'm still going to have the pi over 4. And then I'm going to have, instead of a minus root 3, it's going to be a plus root 3. And then this part is still the same, which is going to be the minus root 3 over 8. I really hope I haven't made a mistake on anything like this. So I have the 9 over 2. 3 pi over 4 minus pi over 4 is pi over 2. And then I have the root 3 minus root 3 over 8. That's going to be root 3 minus root 3 over 8. That is just 7 root 3 over 8, and it's a negative. So it's going to be minus 7 root 3 over 8, which is, multiplying these out, 9 pi over 4 minus, my calculator keeps breaking, times 9 over 2 minus 63 root 3 over 16. That looks kind of big. I don't know. Let's see. This hasn't gone wrong. Okay, so what is my final bit of the strategy? It was, going back to the question, to do the curve 1 minus the curve 2. Okay, so that means I'm going to be doing that the area R is equal to, I need to double this, so it's going to be 2 lots of this one, which was pi over 4 plus 9 root 3 over 16, pi over 4 plus 9 root 3 over 16. And I'm going to minus this one, which is minusing 9 pi over 4. And when I minus this, it's going to become a plus 63 root 3 over 16. Okay, so I'm going to just deal with these as fractions. So that's a 9 over 16 plus 63 over 16, which is 9 over 2. So that's 9 over 2 root 3. And then I have a quarter pi minus 9 quarter. So I'll do 1 quarter. 1 quarter minus 9 quarters is minus 2 pi. And when I multiply it by 2, I get 9 root 3 minus 4 pi. Am I right? So it wanted it in that form. So P is equal to 9 and Q is equal to 4. Oh my God, I really hope this is right. Yes, it is. Q is equal to 9 and P is equal to 4. I actually can't believe that was right. 9 root 3 minus 4 pi. Now, the things in this question that I think are quite interesting was the fact that the integration, I could really save some time in this part of the integration. I was really, really able to kind of get to this stage here so quickly and with all the substitution. I basically didn't touch my calculator. The only time I touched my calculator was to deal with these fractions and stuff that we had at the end there. Cool. I actually can't believe that one worked. I'm going to hope for just a really, really short question for these last couple of minutes that we've got here. Maybe something earlier on in the exam. And I can always do another one of these as if this is something that people have found important or useful. So slide 223. Okay, we'll do this one, even if we can just do the beginning part. We'll do a method of differences question to kind of wrap up this morning that we've got here. Okay. Running out of paper. So even if we get part A of this one done, I think this is from the other live stream that I did before on the back. Oh well. We're going to use method of differences for this. It's saying from r equals 2 to n of the ln of r plus 1 over r minus 1 is always equal to the ln of n plus 1 over 2. So I'm going to start off with that thing that's on the left-hand side here. And obviously I'm going to rewrite this using log laws. So it's going to be the sum from r equals 2 to n of the ln of r plus 1 minus the ln of r minus 1. Nice, easy method of differences here. Just be careful, it does say from r equals 2. So when I do the substitution, I'll start off with r equals 2, which is ln of 3 minus ln of 1. That's when r is equal to 2. Now I'll do when r is equal to 3. So that would be plus ln of 4 minus ln of 3 minus 1 is 2. I'll do r equals 4 to make sure I know what the full pattern is going to be. So this would be an ln 5 minus ln 3. If you want to do another one, which I can do, r is equal to 5, you get plus ln 6 minus ln 4. And then I'm just going to say this would keep going, and I'll do my last two that I would have. So I'd say r equals n minus 1 and r equals n. So if it was an n minus 1, it would be an ln of n minus 1 plus 1. That's just going to be an ln of n. and then this would be an n minus 1 minus 1, which is an ln of n minus 2. And if it's n, you get an ln of n plus 1 and an ln of n minus 1. And we just spot the pattern of where things cancel. So this cancels with this would cancel with this would eventually cancel with this, and this would eventually cancel with this, meaning that we have our final answer is these two, which are plus. So it's my ln of n plus ln of n plus 1 minus ln2 minus ln1. ln1 is equal to 0, so I can get rid of that. So these are going to go into the numerator, so that I have my ln of n plus 1. This is a subtract, so it's going to go into the denominator like this. So we've done those first 4 marks. I mean, those 4 marks were so much easier than this. Then we've got these 3 marks here. Sorry if that question isn't fully shown. No, it is good. We're going to find the exact value from r equals 51 to r equals 100 of ln of this thing. Okay, so it looks like they've got some extra stuff going on. I'm just going to write down what the question is. So that's from 51 to 100, ln of r plus 1 over r minus 1 to the power of 35. Well, I know something that I can do with log laws with this power that I've got, 35. I can put it to the front, and that means I can then put it right outside the whole thing like this. So it's from 51 to 100, ln of r plus 1 over r minus 1. And I know that from 2 to n is this formula. So I'm just going to think carefully about what I need to do for this. This would be 35 lots of, I'm going to do it from r equals 2 to 100, ln r plus 1 over r minus 1. And I want to get rid of everything up to the 50th one. So if I want to get rid of everything up to the 50th, I'm going to have to subtract from r equals 2 to 50, ln r plus 1 over r minus 1. And before I go about this, I want to check that works. Yeah, because that's going to go from 2 to 100 and then from 2 to 50, which will leave me from 51 to 100. So it's going to be 35 lots of subbing n equals 100 and then subbing n equals 50. So it would be ln of 100, this is using this formula here, times 101 over 2, minus the ln of 50 times 51 over 2. I will use the calculator. 100 times 101 divided by 2, that's 5,050. And then 50 times 51 over 2 is 1275. And then I can combine these two things together using subtraction. So it's going to be 35, so the subtraction, which is the division law. So 5,050 divided by 1,275 is 202 over 51. So I think asking what form they want it in, A ln B over C, yeah, it is 35 ln of 202 over 51. So that's A, B, and C. I hope this is right. Yep, 35 ln of 202 over 51 for this part that we've got here. Now, this further math stuff has been so intense today, I have not even had a chance to properly look at the chat here. I have barely been able to see the chat at all. So what I'm going to do is just have a quick look through the chat and see if there's any questions that haven't been answered. If there is anything that you guys would like me to answer now that maybe you've posted about before, now might be a good time to kind of like post some of those questions, because now I'm going to have a look at the iPad and actually read some of the chat. I think in a live stream normally, YouTubers and people doing these live streams have like a lot of time to look at it, to interact with people. But I mean, I was in the middle of doing like polar integration. I didn't even have a chance to even think about what people might be asking me. So it's not like this. If you come to any of my other sessions, I get to see the chat like in real time, and it's a lot easier because it's on the screen with me. So if you've got any questions, I'd be very happy, whether it's about any of these particular parts, to go through that we've got here. What else have we got that I was going to tell you about? Yeah, if you haven't subscribed, it's always good to keep subscribed to the channel so you get kind of these things notified as well. Can you go over how you got the limits for the polar question? Yes. So I'm actually going to redraw that diagram so that we can kind of think about what it looked like. We had something for the polar question where we had a curve that looked like this, and then we had another curve that looked like this kind of shape. Okay. because I wanted to find the area of this whole top section, I was just going to find the area of one single section. And the way that we see areas in polar is they're always being described as kind of like coming out of like rays of light from here. So because I only wanted to find this part, I knew that if I found this whole section, and I'm talking about this part, which I shall do with like a black outline, if I integrated that top curve between those limits, let's just call this one alpha, and this is pi over 2, I knew that I was going to need to subtract from it this part. And that part that we were talking about subtracting is from the second curve. It's from the bigger curve, and it's like rays of light coming out to alpha, and it also finishes at pi over 2. It's just a bit harder to see that it was pi over 2. So that's why I was doing curve 1 between alpha and pi over 2 minus curve 2 between alpha and pi over 2. And now I've just realized it was probably a massive time saver I could have done in that question. I actually could have just done a half the integral of the c1 squared minus the c2 squared with the same limits because they had matching limits. That probably would have saved me a huge amount of time. But again, under pressure like this, I just sort of feel like you don't necessarily always spot those things that we have. Okay, let's see what else we've got here. How do you know which limits to use in polar? Yeah, the polar stuff that we just talked about. How many? I think I'm going to try and do a couple of these per week. I am going to try and do a schedule for these. It's just at the moment I'm like I've been up and down between London and Manchester, so it's a bit hard to know when these things are going to be done. But if you want to, you can always catch up on them afterwards in the live stream tab on my YouTube channel, and you can always follow me on Instagram. If you follow me on Instagram, you'll see like when I'm going to post that these things are going to be happening as well. I'm so sorry I neglected the chat so much. My chat was really heavily neglected today because I was just doing so much stuff here. Yeah, so actually just answering Sophie's question, the reason I did half of all of it, first of all, the half actually just comes up in the standard formula. So that's just like how it comes up in the formula. But I was concentrating on just finding one part of this diagram. And then afterwards, because they wanted the whole section, I needed to double the area at the end to do that. So I suppose I actually could have doubled them at the beginning and got rid of these halves in both ways. There's lots of other ways you could have done that, maybe that would have been even simpler. But again, like I'm saying, under pressure, it's quite easy to miss some of these things as well. Why did I have to add pi to my negative angle answer? Oh yeah, so when I did the part D, this is to Jamie's question, I had to add pi onto it because I had a negative angle answer, and then that would have given me a negative time and for when the foxes and rabbits were on the island, and I don't want to have a negative time. So for tan, because it repeats every pi, I added pi onto it when I was trying to fix that answer that I had done incorrectly there. The pens that I use are these Uniball pens. They're so good. They're really, really good pens. I like those. For the matrix question, if the simultaneous equations were multiples of our initial matrix, what would we need to do hypothetically? If the simultaneous equations were multiples, you could take out a factor, or you could actually, that's a good question actually. What you could do is you could divide everything in the equation by that factor that they'd been multiplied by, including the right-hand side, and then you could just proceed with it as like a normal question because the solutions would still be the same solutions if everything was divided through. Francis, I'm very pleased that you've watched this. It tells you like how much crazier maths can get as well. On the polar equations, how could you tell what was curve 1 and what was curve 2? I know it's really, really hard to see, but you get the sense because the curve was like a 1 minus sine theta times 3, and the other one was a 1 plus sine theta. There's something that feels like similar about the shapes, and they usually are really smooth. So that's how I could tell that that first one was that sort of smooth shape, and then the second one was this smooth shape that was on the outside as well. The next live stream I'm going to be doing next is statistics, I think. I'm going to try and do statistics probably on Tuesday this week. And then after that, I'll have a better idea of when I'm going to be doing these things. To Harry's question, do you recommend going through the Google Drive on topics that we are less confident with? I thought this might mean that when I do exam papers, I've already seen the question before and so less useful. No, I think it's a really good idea because training yourself with the topic-based exam questions does mean that when you see them again, you'll be better, but then you build your confidence. And this is the thing. Sometimes people use exam questions just to measure how well they're doing. But what I really want you to see is that exam questions are not only a way of measuring how well you're doing, they are a training tool in their own rights. Okay. They are a way of you actually training yourself to get better at things. So please do use that as a training tool. What else have we got? I'm not going to have time to try the question on page 25 because this is actually meant to be finishing right now, I'm afraid. I did miss vectors, but I might do another one of these kind of again. I might do some of these kinds of questions. You could get asked to draw polar graphs. It would probably only be like 2 marks, and most people have a graphics calculator. So I think they're starting to steer away from this kind of stuff as well. Yeah, the specimen questions. I don't think I'm allowed to share the specimen questions because they're locked on the Edexcel website, which is why I haven't been looking at any of the specimen kind of questions as well. What resources would I recommend with the build up to CP1? You've previously used MADAS, but I'm running out of questions, and you've also done the Google Drive. Okay, I would probably recommend looking at some of the international papers for that. It's very easy just to go to international, like either FP1, FP2, FP3. You'll very quickly see which topics are in which ones, and you'll just get some fresh questions from those kinds of things. That was to Azimo at that particular point. And then to Jamie, you have your Google Drive with questions on Corpio, but are there any stuff for the optional modules? Unfortunately, Jamie, I've had to put the optional modules for the members only because I've been spending so much time on that, on all of those sort of that content. So to get to that members only drive, there's a post about it for the members section. So those questions by topic, I'm afraid I've only got those in the members only drive right now that we've got. Okay. I probably might do a live stream for some of the further modules. I'm not sure about this. Yeah, Araful's here. Hello, Araful. Araful is one of my excellent students when I was a teacher in Morpeth, and I know he's just about finished his 3rd year exams. Is that right, Araful? How have your 3rd year exams gone? I hope they've been good. So I hope you are coming up to the end of your uni experience, and I hope it's been really good. I am maybe going to do further maths module streams. I'm not sure. Next thing is going to be normal stats in my live stream. Okay, so normal stats is going to be the next one. Yes, of course. I do recognize your name, Azim. Azim, you're brilliant in the paid for sessions. You're brilliant in the live streams. Azim, tell everyone that you've liked the sessions. If you can tell everyone what you've thought of the sessions and that they can still get the recordings, there's a link to that in the description. So yeah, if Azim thought that the core pure, if anyone who came to my paid for sessions thought they were good, yeah, tell everyone in the chat what they thought about it. Because that would obviously be very useful for me as well. Because yeah, I just want people to be able to see those classes and benefit from all of that kind of stuff. Oh, I know. I do need to do an everything you need to know for decision. Decision is is the bane of my life. I do not like decision very much, but I will do it before the exams. It might not be like well before the exams, but it will happen. Okay, it will happen. And of course, I recognize Breezy. I know who Breezy is as well from the Discord group. So I've got some good people supporting me here today. Right, guys, it's 10:36. I've just had too much fun doing all of this crazy mechanic stuff. I think not mechanic stuff, crazy core pure stuff. I think this was the hardest question today, the foxes and rabbits question. But tell you what, doing maths, by being watched by someone doing maths whilst you're doing maths is really intense. And it's really intense doing it when you've never prepared, when you haven't prepared for the question. So there's probably some things here today that I could have done more efficiently, more quickly, but it is what it is. So you can always try and improve on them, and I might see some of that in the comments later on. Guys, I am going to log off from here now. I'm just seeing what have we got here? Yeah, it's great to hear from Araful. Thank you so much. Good. Oh, you've got 4 exams left. I really hope they go well. Guys, I will see you in another live stream soon. Have a lovely weekend. Sorry to make you get up on a Sunday morning for this. Hopefully it means you'll have some more time to do some revision for the rest of the day. Because tell you what, next few weeks will be hard work. But then after that, it's all going to be good fun. Okay, guys, I will see you later if I can figure out how to stop this here. Okay, see you later. Bye.